Hello guys, welcome back to Abstronic Circuit tutorial. Now let's discuss how the stable mode working by using any 555 timer IC. Initially, the voltage of the capacitor is 0 volt, while the capacitor charging the output of the comparator 1 will be logic high, simply because the non-inverting input is greater than the inverting input. So when the output of the comparator 1 logic high, then the flip-flop circuit, the setting will be activated. So this time, the capacitor is charging. At the same time, when the output of the comparator 1 logic high, then the output at Q from the flip-flop circuit will be logic low, and when the output is logic low, then the output from pin 3 will be logic high. At the same time, 0 volt injected to the non-inverting input of the comparator 2 from pin 6. And the inverting input 2/3 of the VCC, which is 12 volt, so therefore equivalent to 8 volt. 8 volt, the inverting input is greater than 0 volt, the non-inverting input. Therefore, the output of the comparator 2 will be logic low. So when the output is logic low, then the reset of the flip-flop circuit will not activated. So therefore, the output at Q from the flip-flop circuit remain logic low, and the output from pin 3 also remain logic high. But when the capacitor voltage reaching 1/3 of the VCC, which is 4 volt, then the output of the comparator 1 will be shifting to logic low. So when the output shifting to logic low, then the output from Q of the flip-flop circuit will be remain logic low, and the output from pin 3 also remain logic high, since the comparator 2 output is logic low. So when the capacitor reaching 2/3 of the VCC, which is 8 volt, then the output of the comparator 2 will be shifting from logic low to logic high. So when the output is logic high, then the reset of the flip-flop circuit will be activated. So when it is activated, then the output from Q of the flip-flop circuit will be logic high. So when the output from Q is logic high, therefore the output from pin 3 will be logic low. At the same time, when the output of the comparator 2 is logic high, then the capacitor will be discharging. So simply it means the capacitor discharging when the reset of the flip-flop circuit activated and charging when the set of the flip-flop circuit is activated. Since the output from Q of the flip-flop circuit is logic high, then the discharging transistor will be activated. So when it is activated, then the current from the power supply will be discharging through the transistor via resistor 1. At the same time, the voltage from the capacitor also discharging through the transistor via R2 until the voltage from the capacitor decline or dropping to 1/3 of the VCC, which is 4 volt, then the output of the comparator 2 automatically logic low, and the output of the comparator 1 will be logic high. So this time, the output from Q of the flip-flop circuit will be logic low, and the discharging transistor automatically cut off, and the output from pin 3 will be logic high. At the same time, when the output from comparator 1 logic high, then the set of the flip-flop circuit will be activated. So this time, the capacitor starting charging at 1/3 of the VCC rather than discharging to 0 volt. Now, let me show you how the stable mode working from the external to the internal of the NE555 timer IC by using this animation. Now, you can pause the video tutorial to look how the stable mode working and how the capacitor charging and discharging, and how the current flowing from the circuit. So guys, thank you for watching my video tutorial. So don't forget to subscribe to my channel, like and share.